Okay, good morning, class. Today, we're going to start our last section of Unit 6. And our topic is parametric equations. Our homework tonight is going to be section 9.5, page 1019, and problems 1 through 20. Okay. Up to now, we've been representing a graph by a single equation involving two variables. So our graphs have a single equation involving two variables. And for the most part, mainly for us, it's y is some function of x. So consider the path of an object that is propelled at a 45-degree angle. And it has initial velocity of 48 feet per second. So what would that graph look like? What could it look like? Well, an equation to represent this would be y is equal negative 1 over 72 x squared plus x. And the graph might look like something like this. So at a 45-degree angle, you might see something like this. So what we know looking at this graph is that y is a function of x. So if the object is shot out from the origin at 0, 0, when the object has gone horizontally 36 feet, it reaches a height of 18 feet. When the object has traveled horizontally 72 feet, it's back on the ground with a height of 0 feet. Okay, so at x equals 0, y is 0. At x equals 36, y is 18. At x equals 72, y is equal to 0. So this graph does give us information. What if we wanted to know instead at what time does the graph reach 18 feet? Or what time will this object travel 24 feet? What would the height be at that time? So this particular function that we have cannot answer those questions for us. So this graph tells us where an object has been, but not when. Okay. So this function tells us where the object has been, but not when. So it's the when that we want to focus on. So it doesn't tell us, but not when the object is at some point x, y. So what we're going to go over today is how to find the when. So to determine this time, we have to introduce a third variable, t, which is called a parameter. So if we want to find out the when, we have to at least introduce a variable that represents time. This third variable, so now we will have the x, a y, and a t. This third variable, or the parameter t. So for the above example, and we'll learn how to do this later, but the equation that would represent this would be x is equal 24 times square root of 2 t, and y is equal negative 16 t squared plus 24 square root of 2 t. X and y have to be continuous functions of t. And the path taken by the object is called a plane curve, capital C. Okay. So we've introduced, so we started off with y is equal to negative 1 over 72 x squared plus x. To determine the when, we introduce a third parameter called t. Then we're able to take that function in two variables and rewrite it in terms of x with respect to t and y with respect to t. The actual graph is going to be exactly the same, so I will show you that in a minute. The path that the object is taken is called the plane curve C. The variable t is called a parameter, and x is equal f of t, so x is some function of t, where f of t is continuous, x is continuous, and y is some function g of t. So in the above example here, our f of t would be 24 square root of 2 t, and our g of t would be negative 16 t squared plus 24 square root of 2 t. And those have to be continuous functions. But these two functions, x is equal f of t and y is equal g of t, these are called parametric equations. So these are your parametric equations. The other equation, y is negative 1 over 72 x squared plus x, that's a rectangular equation. So you should see kind of a recurring theme. When we dealt with polar, we had polar equations, we had an equivalent rectangular equation for them. With the complex, we had rectangular equations, and we were also able to rewrite the complex in terms of polar equations. Vectors, same thing. All right, so how do we graph the plane curve? So we're going to take a look at that. Okay, so to graph the plane curve, first thing we want to do is we need to select values of t. On the given interval. Next, for each value of t, we're going to compute x and y. Then our third and final step is we're going to plot these points, plot these xy points. So plot the points x comma y in the order of increasing t. So wherever your t starts, that should be the first point plotted. Once you have all of your points plotted, then you're going to connect those points with a smooth curve. Okay, so again, we're going to select values of t on the given interval. So whatever interval is given to us, we're going to choose our values of t. For each value of t, we're going to plug that into our x is equal f of t and our y is equal g of t. That will give us an xy point, a point in terms of x and y. Then we're going to plot all of our points, and in the order of the increasing t, we're going to connect those points with a smooth curve. All right, so let's take a look at an example. Let's say we have parametric equations, x is equal t squared minus 1. Y is equal 2t. And we're going to plot this graph, smooth this plane curve on the interval t between -2 and 2. So t is greater than or equal to -2, t is less than or equal to +2. So the first thing we're going to do is we're going to set up a table. So our table will have t, x, and y. Okay, so our first t value will be -2, then -1, then 0, then 1, and then finally 2. Okay, we're going to go ahead and evaluate these points in our head. So when t is equal to -2, x will be -2 squared, which is +4, minus 1. So x is 3. At t equals -2, y is going to be 2 times -2, which is -4. When t is equal -1, we're going to get -1 squared, which is +1. 1 minus 1 is 0. So x is 0. when t is negative 1, y is going to be 2 times negative 1, so that'll be negative 2. At time t equals 0, x will be 0 squared, which is 0, 0 minus 1, so it's negative 1. Y is going to be 2 times 0. 2 times 0 is 0. At t equals 1 second, x is going to be 1 squared, which is 1. 1 minus 1 is 0. Y will be 2 times 1, so that's 2. And finally, our last point in our interval, when t is equal to, x will be 2 squared, which is 4. 4 minus 1 is 3. Y is going to be 2 times 2, which is 4. Okay. So now that we have our chart here, we're ready to graph our smooth curve. Right, so let's go ahead and do that. Okay, 1, 2, 3, 4. Okay. So we're graphing the points x comma y, evaluated at certain times t. But notice you're not going to graph the t. So at t equals negative 2, our first point in our graph is going to be 3, negative 4. So it's going to be a point down here. When t is negative 1, we're at 0, negative 2. So we're here. At t equals 0, we're at negative 1, 0. At t equals 1, we're at 0, comma 2. 0, comma 2. And at t equals 2 seconds, we're at 3, comma 4. We're up here. Okay, so now we're going to connect with the smooth curve of our graph. So our graph does this. And then we will draw arrows to let us know the path of this particular object. Okay, and that's it. That's all you have to do. The first part of your homework, 1 through 8, you're going to be given parametric equations, and they're going to ask you to evaluate or to calculate what x and y are at just one particular value of t. For 9 through 20, you're going to go through, and that's where you're actually going to graph. So you're going to do the same setup that we did here. Create the table, plot the points, draw the graph. Okay, there should be graph paper up in the cubicle, so you can grab as much of that as you need. And this homework is going to be due on Tuesday. All right. So before I go, I'd like to say congratulations to boys basketball for winning last night, and good luck to girls soccer tonight. All right, I'll see you guys on Tuesday.